My name is Bjarne Decker and I'm responsible for the computer science laboratory. Our job, that is to put research to work. And our main challenge, that is how to program large real-time systems as efficiently as possible. And after many experiments, we decided that we had to move from conventional high-level languages such as Ada, Chill, C++, etc. into the world of declarative programming. We also found out that the only way to do that was to develop our own language, and a language which is called Erlang. In this video we'll show you about the properties of this language and how it's been applied in large prototyping projects, and also about the potentials of this language for the future.
Declarative programming languages have several advantages over traditional languages. For example, programs in such languages are considerably shorter than the equivalent programs in imperative languages. Here, for example, is a program in C. And here is the equivalent program in Erlang. They also encourage clear programming styles. For example, an object-oriented programming style or the implementation of an abstract data type is simple in Erlang. Up to now, declarative programming languages, such as Prolog or ML, have not been used for real-time applications, so we've had to add a notion of concurrency and real-time to our language. We have also added a sophisticated error detection mechanism. This allows us to program robust real-time systems. Declarative programming languages are of course also symbolic, and we'll start by showing you the symbolic nature of the language in a typical telephony application.
Erlang is a real-time declarative programming language. But in order to experiment with such languages, you need more than just a computer. You need a real-world application and real hardware to run it on. Let's go into our lab to see how we've done this. And this application is based on telephony. We have programmed an Ericsson MD110 PABX, this PABX you see here, using Erlang. But that's not really quite true, because we've changed the standard MD110 very, very slightly so that it communicates with the Sun workstation. And the Erlang programs we are going to be running are actually running on that Sun workstation, not on the PABX itself. This has been done by connecting the hardware signals through from the PABX to the workstation and vice versa.
Here is our standard Erlang environment. We're running X windows on a Sun workstation. We have an Erlang interpreter window here and an Emacs editor window here.
Okay, let's just make a normal call just to see that the system works.
Hello, Mike.
Hello, Joe. System working?
Seems to be.
Okay, fine.
Okay. Right, we're going to do that again, only this time we're going to look at some of the symbolic information that's available in the system while we're placing a call. I'm going to dial Mike again. 1, 6, 7.
What we see here is a symbolic trace of the communications to and from the number analyzer. It first received the message analyze 1. It returned the result get more digit. It then received the request to analyze the digits 1, 6, and again returned the result get more digits. And lastly, it received the request to analyze the digits 1, 6, 7. It then returned port 67, which signifies a hardware address of a telephone.
I'll now dial an incorrect number. 1, 6, 9.
Here again we see a symbolic trace of the communications to and from the number analyzer. Again, it got the request to analyze the digit 1 and return the result get more digits. Then it got the request to analyze the digits 1, 6 and again returned the result get more digits. Finally, it returned the it got the request to analyze the digits 169, but this time it returned the result invalid, as this number is invalid.
Okay, we've just shown you one of the properties of the language, that it is a symbolic language and that symbolic information is always available. I'd now like to show you another property of the language, and that is how we handle errors. And in order to show you this, that I'm first going to make a perfectly normal call, as I did before, to Joe from this telephone. Hello, Joe.
Hello, Mike.
Okay, I'm now going to leave this call set up from this phone here, and I'm going to make another phone call to Joe on his other telephone. We'll use this phone here.
Hello.
Hello, Joe. Okay, we have now made a call to Joe. I'm going to make a call to Robert. Hello, Robert.
Hello, Mike.
Well, I now have a phone call set up to Joe and one to Robert. Of course, I can go backwards and forwards between the two of them. Hello, Joe.
Hello, Mike.
Hello, Robert.
Hello, Mike.
Well, now I'm going to do something which means that the system goes wrong. And what I'm going to do is that I'm going to try and put the calls into a conference. So I'll press this button here, which should put them into a conference. And as we can see by the screen, things are starting to go wrong.
We see here that something has gone wrong. An error has recurred. Here is the original error which caused all the subsequent errors. It also caused those parts of the system taking part in that error to automatically restart themselves. For example, here is one of the telephones that took part in the call which crashed and was subsequently restarted automatically by the system. We shall now try and find out what caused the original error. We see that something was undefined. We also see that it was the function mmulti in the module feature which was undefined. We shall now go into the module feature and try and correct the error. We are now in the module feature and we'll try and find the call to mmulti. Now I know there is a function called justMulti, so this seems like it could be a spelling error. We will try and correct it, save the file and load it again into Erlang and see if it works. We are now back in the Erlang window and we'll load in the corrected module feature. And restart the system to see if we actually corrected the error.
Let's see if Robert succeeded in fixing the error. I'll do the same thing again. First I'll make a call to Joe.
Hello, Mike.
Hello, Joe. And I'll make a call to Robert.
Hello, Mike.
Hello, Robert. Now I'll press the conference button and see if it works this time. Hello, Joe.
Hello, Mike. Hello, Robert.
Hello, Joe. Hello, Mike.
Hello. Well, it worked this time. Well, I'll leave Joe and Robert to talk to each other and go out to the conference.
Hello, Robert.
Hello, Joe.
I think you managed to fix the bug then.
Yes, finally.
Do you remember before we went into conference, we set up a call? Well, let's see if that call is still running. Hello, Mike.
Hello, Joe. Okay, I'll finish this call. Well, what you've seen now is that this call was totally undisturbed by the fact that we have had an error in the system in other calls, that we've reloaded parts of the system software. This call here still worked. And the interesting thing is it would have continued to work whatever state the call was in. It could have been ringing, we could have been dialing, we could have been between dialing digits. Whatever had happened, calls in this system are completely independent of each other. So an error in one call will never affect an error in one call will never affect the correct operation of other calls. You have just seen our language Erlang and the telephony application which we run using Erlang. But in fact, our application contains many more features. What we've implemented is hot number, warm number, short number, diversion, diversion on busy, 911 emergency, blacklist of incoming numbers, transfer, conferencing, directed call pickup, call waiting on busy, call waiting on no answer, and intrusion. Erlang has been used outside our laboratories by Ericsson for a large-scale prototyping experiment. Their findings agreed completely with ours. Programming in Erlang leads to at least a factor 10 improved programmer productivity. Erlang programs are concise and elegant. In fact, they are about 7 times shorter than equivalent programs written in C. It's easy to write robust systems in Erlang. And of course, all this leads to very short lead times.